My name is Ben Harvey, Senior Building Manager. Today we're going to be carrying out a pre-pour inspection of our upper roof slab. We're going to be following the Willmott QD checklist as a guide, and we're capturing this by form of small video clips. So now we're going to head up to the upper roof slab, right up there, to carry out our pre-pour. Here is an example of the Willmott QD checklist that we will be using as a guide for this technical training. We will be following the in situ concrete frame checklist, as this provides the relevant items to check. Once we have completed the prepare and plan section, where we refer to the drawings and specification, we will go and check the works. There are 12 items to review under the pre-pour section, such as checking the reinforcement, the surface penetrations, the setting out and the formwork. Once the pre-pour has been signed off, the concrete can be placed. There are 8 items to check during and after the pour, such as checking the actual concrete delivered, the vibro compaction, the correct cover, and also taking samples of concrete which will be sent to the lab for strength testing. We will be looking at these in detail over the next few video clips. When the pour is complete, there must be adequate protection in place and ensure the finish is left clean. This is also checked and signed off on the checklist. Once the concrete cube results are returned and the concrete has met the specified strength, usually within 7 days, the checklist can be signed off under the closure section, and the remainder of the payment can be released to the subcontractor.
In 1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire the A-Team.
We have an operative taping and capping over SVP in this case. This is also done to the rainwater pipes. This is to ensure that we always have a clean pipe all the way through our build, and also it stops the falling debris going onto the operatives below.
Here we can see all the debris being blown out from under the reinforcement by using an air lance connected to a compressor. This is to ensure the ply formwork beneath is clean and free from debris, therefore giving a full coverage of concrete under the reinforcement and giving a smooth finish to the underside of the slab. A magnet is used prior to this to remove the tiny wire offcuts so they are not blown around and potentially causing harm. Let's go.
Here we have the L bars to the upstands. These were installed as additional bars to avoid the shear stress with concrete precast columns. We also have 12mm well bars from the interface of the parapet and the main rebar mat. This should be tied in at 40 times the bar size to the top mat for the laps. This is also to ensure they do not have any weak points in our slab.
That's it.
This is showing the punching shears to the roof columns. This has been progressive as we have come up the floors. The detail that I'm going through at the moment is denoted as detail A on the structural engineer's roof slab reinforcement drawing. All calculations are done by the structural engineer. They will state on the drawings the dimensions and the size of the bars that are required to take the structural load. In this instance, there's a lot of load going around the columns. Referring back to the RC drawings, I'm checking the top one, the top two, which is is top mat 1 and top mat 2 for the 18 bars stated. This means that we've got 18 bars going one way, you should have 18 bars going the other way. The reason why the additional bars were designed around the columns by structural engineers is to ensure that the movement for the columns will not affect the roof slab and can cause potential cracks, deflection, as this is an intersection. We have installed shear links around the columns. To describe the shear links, they look like hooks. They hook onto the top mat to the bottom mat. They are designed to also avoid the stress going around the column and to strengthen the area around the column to the slab. It is imperative to make sure this is installed correctly to avoid any slab failures and potential column failure.
Here we are checking the upstand base around the slab perimeter, ensuring there is enough cover around the reinforcement, which should be 30mm as per the drawings. This is a finished slab port ready to set the upstand, showing a recess formed in the formwork to help with the bond, and also rebar holes so the shuttering can be secured. The concrete has been scabbled to give a rough textured surface to provide a sufficient bond for the pour. The starter bar is then checked against the RC drawings and the chamfer fillet to the top. This is a section of finished upstand showing the chamfer and the smooth finish. Here we are checking the slab interface with the precast lift shaft walls. When the precast wall is formed off-site, it has a quicker strip type reinforcement cast in. The bars are bent out and tied into the top and bottom mat of the slab reinforcement. Checks we make are to ensure the reinforcement is sufficiently tied to both the top and bottom mat and that the correct dimensions are achieved as per the RC drawings.
Here we have an operative producing sample cubes for testing.